All right, hello and welcome back. My name is Cameron Kirk, and this is video 3 on my network programming series. And in today's video, we're going to be talking about what's the deal with IPv6. So, most people use Google, just as an example. When you go to google.com, you use www.google.com, or maybe you have a bookmark or a shortcut. But the bottom line is you know the URL of the website you're trying to go to. So if I ping google.com, it's going to come back with an IP address. It's going to convert that domain name, I'm going to cancel out of this, into an IP address. And what we're seeing here is actually a IPv4 address. So let's see here. Over here, is that there? And a IPv4 address is just simply 4 8-bit sections separated by periods. That's exactly what we have here. And these values are displayed in decimal. So these are your regular decimal values that we know and love and we learn in kindergarten. But it is 8 bits that make up each of these fields, or 1 byte. And with that said, that means that these have a maximum, well, each field here has a maximum value of 255. So that also leaves us with a total of, well, let's write this out, 4 8-bit fields. That equals 32 bits. Okay, so if I jump over to the calculator and I can switch over to programmer mode, and I can do F, that's 1, 2, 3, 4 bytes. That gives us this many, well, not including 0. Let's copy this. What this value represents is this is the number of possible values unique values that we can have under IPv4 for 8-bit fields. So once we get past this, there are no more unique values. And this is the address of a server. So if you have a public IP address, you know, it's sort of like houses. Like, everybody needs a unique address so that if you're going to an address, it's not going to take you to 2 different places. It'll take you to 1 place. That's how addresses work. And unfortunately, it is a huge topic that we have known for probably the last 30 years now, that this, their allocations, the way they divvied these addresses up was not efficient, and so on, and we're running out, and we have ran out of IPv4 addresses. You can go Google it. You can see lots of topics talking about it, that we've ran out of IPv4 addresses. There's a whole Wikipedia page talking about the exhaustion of IPv4 addresses. You can go check that out if you are interested. So what is IPv6? IPv6 is the solution. It is the way forward. It is supposed to be replacing IPv4. And what IPv6 is it is a 8 groups of 4 hex values, and we're speaking about hexadecimal. And just as an aside, 2 hexadecimal values equals 1 byte. So I just have a random example of an IPv4 address, and there it is. So these values are displayed in hexadecimal. They are not displayed in decimal like we have up here. They're also separating the groups with a colon rather than a period. And this is pretty big. It is 128 bits, which is much more than 32 bits, which means we get much more than this value here. And as a matter of fact, I've tried this example before. I don't know, I haven't tried doing it this way. So unfortunately with this Windows 10 calculator, I can't, that's 2 bytes 4 bytes, 6 bytes, 8 bytes, and I can't put any more. It's full. But maybe I can try this. Let's head over to the scientific calculator, and we will do 2 to the power of exponent. There it is, 128. It's a big number. Yeah. I don't even think that's right. I think that's going to be even more than this. Well, hold on. Let's try 2 to the power 32. Yes. So let me copy that. That is exactly what we had over here. Same number. Okay, so that was correct. But even still, the calculator won't display what is 2 to the 128. It is a massive amount of number, or it is a huge number. It is a massive number of IP addresses for public servers, public IP addresses. So let's see it one more time. 2 to the power of 128. So 3.4, and then move the decimal point to the right 38 times. And that is how many public IP addresses we have. So that is very clearly why there's a problem. We've ran out of IP addresses. This was not enough. But this very clearly means we have far more than we'll ever really need. And why should you care? So the bottom line is if you have any experience at all with economics, you know that when something is scarce, when something is running out, it costs more. So what is the incentive of IPv6? Well, they are more plentiful. They are far more common. As a matter of fact, they are so plentiful that they should be dirt cheap compared to the original IPv4 address. One other thing I wanted to explain was talking about how to write these IPv4 addresses. There are 2 rules for writing shorthand. You can omit leading zeros. So that's a leading 0. We'll take that off. These are leading zeros, so we'll take those off. And the second rule is one set of consecutive zeros can be replaced with double colon. So this is a set of consecutive zeros. We can just take them off. And then we know that those are zeros in between there. And we know there's going to be 8 groups total. And one thing that is important to note is you cannot do this multiple times. So what I mean by that is if we had another set of consecutive, if we had like 2 different sets of consecutive zeros, you can't replace both of them. Only one can be replaced. You can only do that one time. Very cool. So if IPv6 is more plentiful and they should be cheaper, are they cheaper on Azure? Well, before we take a look at that, let me just show you one thing very quickly. Let's jump over to Azure. If I head over to cost management, I have a resource group that has been running the cheapest server that Azure has to offer, basically 24/7. And yeah, it's this resource group here. And if I switch this to the last 30 days, we can see that having this running for the last 30 days has costed me $6.36. And if we see the breakdown down here, we see that the virtual machine costed me $2.39. And this virtual network cost me more than the compute resource, more than the virtual machine. So what's going on there? If I click on the virtual network category, we can see a cost breakdown of that. And so whatever's in this virtual network is costing more money than having the compute resource itself. So whatever this is, it's costing more than it costs to have that computer, that virtual machine. And lo and behold, it is actually, I don't know if you can see that, it's actually the IPv4 public IP address that I have that's cost more money than the compute resource itself. So this one public IP address is basically half my cost. So as it turns out, Microsoft actually offers the IPv6 offerings for free. So you can get a public IPv6 address for free on Azure. This is fantastic. And this is showing the benefit of IPv6 technology. But here's the kicker. Azure right now, at the time of recording this in 2023, they are forcing you into an upsell. So if you want to handle IPv6 traffic on your IPv6 public IP address, you have to pay for other features, other components offered in Azure, which costs more money. So basically, if you're going to handle IPv6 traffic, you want to have a server on Azure that has IPv6 traffic. It's not more cost effective, it's more expensive, which really doesn't make sense. So with that said, I am not going to be covering how to set up a IPv6 server for our project today. Instead, I've done something better. I'm going to save you the time. I'm not going to explain how to do it, because without a doubt, if Azure wants to be competitive in the cloud sector, they want to compete with some of the other cloud providers. They could really cut costs here. So for small deployments. So what Azure could do is they could lower the requirements and say, you know what, we've improved our technology. We've now made it cheaper for you to have an IPv6 server. Come over to Azure and we're going to help you out. But at the time of recording this, that is not true. It is in fact more expensive to have an IPv6 server on Azure. So here's my solution for you. We're not going to cover how to make an IPv6 server on Azure, on an Azure virtual machine, because without a doubt, I believe Azure is going to change this. I believe that the markets, the economies of scale are going to come through, and they're going to tell Azure, hey, you can improve your technology, you can make it better. So I've created this one-click button here that says deploy to Azure, and you click that, and it will spin up everything into your Azure deployment. And as a matter of fact, I'm going to click this right now. Okay. And so when you do that, it brings you to this form that you need to fill out, and it tells you that you're getting 9 resources with this template. You can edit the template, edit the parameters, visualize. We're not going to, well, we can visualize it just for the heck of it. What this is going to, well, I don't even really want to spend any time on this. You can inspect this for yourself on your own time, but this is the bare minimum that is required, very, very minimal. Everything you need to handle IPv6 on a IPv6 server on Azure. So you just need to pick a resource group. I have socket programming, which is empty right now. Give it a username, give it a password. Click next, and click create. Okay, so we'll let that run and we'll come back when this is all done. Just a quick note before we do that. When we spin this up, it's going to cost a little bit more than running a bare essential server with an IPv4 public IP address. But as quickly as I'm spinning this up here, you can just delete it all out just as fast, and you're not really going to be charged much of anything at all. Okay, so we'll come back when this is done. Okay, we are back, and that is all done. I am in the resource group that I just deployed that template to using that one-click button that we saw just a moment ago. And we can see everything's here. This is everything required today in 2023. It is April. This is what Azure requires you to have to use a public IP, IPv6 public IP address in Azure. So we're going to get this virtual machine here. Let's go ahead and get connected to it. If I switch over to SSH, that template, that one-click button has done everything for you, including giving SSH access to your virtual machine. So all you need to do is come down here, and we're not going to be using a private key path, but go ahead and get that username @IP address. And let's head over to terminal, and we are going to SSH, paste, enter, say yes, provide that password that you just set up for this virtual machine, and we're in. So as usual, the lighter screen background, that is going to be my client, my local machine. You can see right here it says Kirk PC. And the darker background, that is going to be the server out there on the real cloud, out there on the internet. So we got nothing on this system. We're going to need a C compiler. So right away, let's do sudo apt get install build apt apt get install build essential. Hit enter, say yes, and we'll let that go. And while that is going, we'll come back when this is done. Okay, we're back. Let's jump over to our client side and let's start talking about that server code and what we're going to have in this video 3. So let me jump into my repositories, and I'm going to code our network programming website or GitHub repository. So that'll open up. And right now I'm working on the branch video 3, but the link is in the description, and you'll get access to that neat button that I was just showing you. This button right here, you'll get access to that, and you're also going to get access to the server code, which is what we're after. I'm going to merge this into the main branch. So let's talk about what we have here. I'm actually going to make the font size 1 notch bigger just to make that a little bit easier to read. And yeah, so this should look familiar if you were able to bear with me in the last video. This is basically saying what port you want the app to run on, how many clients can get in line while they wait to connect, and we have all of our standard header files. We're going to be using time here, so we're going to be basically telling the clients the time as soon as they connect, and then they go away. We close the connection after we tell them the time. Something really simple. This line of code here, this was something that I dug up on the internet. Basically, I wanted to know how can I control hitting Control C, because basically I want to make sure that the server closes down and shuts down the socket, and I don't want Control C to just break out of the program. So Control C is a keyboard interrupt, and we're simply handling that interrupt using this function here, and then this function is setting a stop flag, which starts out as 0 and then it switches it to 1, and that basically allows our server code to know, hey, it's time to close up. We have the stop signal coming in. So down here we have a buffer. We have various file descriptors being defined. We're tracking how many bytes we're going to send. This here is interesting. We'll see this later on. This is a standard HTTP response header. So as we'll see in this demo, this allows browsers, web browsers, so like Chrome or Edge, if our server sends out this information, then it allows browsers to understand the data it's getting from our server. So we're going to send this out, this very specially formatted string here, to our clients that connect, and that allows browsers to work. We're going to be talking more about this response header and how to add other functions to our server in future videos. These are variables to hold our time data. And these are variables to hold our client address. So if you went through the last video, some of this stuff should be looking pretty familiar, especially this stuff here. The reason why they're up here is because what I've done is down here where we're actually accepting connections from our listening socket. That's all in a loop, and you don't really want to define variables over and over again in a loop. That, you know, bad things can happen if that occurs. Okay, so this is where the magic happens. This code should also look very familiar from the last video. This is our hints address info struct, which we discussed in the last video. If you're getting a red squiggle on hints from IntelliSense on Visual Studio Code, check out the last video. I do have chapters enabled, so you can skip to the exact section on how to fix that problem. And this right here, this one line of code, This is what takes our server from listening for IPv4 connections coming in to now it is handling IPv6 connections. This one line of code right here, and that's it. So IPv4, suddenly it's IPv6. It is that easy, that simple. This should look familiar. Everything else is pretty much going to look the same as before. So we're creating our socket, we're binding to the socket. What's missing here is I don't have that code that is going to basically traverse the list of addresses that can be used on this bind address. I'm just simply using the first one on there, and that's okay. And then we're turning it into a listener, so we're listening for connections using that server file descriptor. Okay, so here's the while loop. So basically forever, while the stop flag is not set, keep looping. And as soon as the stop flag is set, we're going to finish this loop and we're going to close down. And then this pretty much looks like the server code that we saw before. So we're waiting for a connection. The client is connected. We're not going to listen to any of the client's requests. We only have one function, and so we're going to just send a response and then close the connection. The reason for that is because of our Azure implementation here. Azure has upselled us into using a load balancer, which really is not necessary for this demo, but we have to use it. And part of the nuance of using a load balancer on Azure is you have to make the health probes happy. So a load balancer has a health probe, which is basically like a little probe that connects to your socket, and then it will go away, and that's it. And so if the health probe thinks that your server code is not working, it'll report back to the load balancer and say, hey, this VM isn't working, don't send any connections to it. And the load balancer will not send any connections to your server. So this whole thing, the whole Azure side is kind of hacked together, and it's a little bit beyond the scope of this video. I will be making a follow-up video in the future, especially if how they require you to create your IPv6 servers changes. I will be covering that in the future. But for now, we're just going to sort of brush it under the rug and not worry about it in this video. So we close down the client and we start over, we come back up, we get the next client that's out there waiting. When the shutdown signal is received, we are going to shut down the server or the listening socket with option shut RD. And I think I can get it to say what are the different... RD means no more receptions. And we're finished. Very cool. So let's head over to our server. I'll type clear. I'm going to type vi server.c. I'm going to hit Control A to highlight everything and copy it. And then I'll hit the I key for insert. You can see on the bottom left it says we're in insert mode now. And I will paste, and that just pasted all the code. I'll hit escape :WQ, not capitalized, :WQ, and that is written. We're going to compile that. I'll do -o server, and now we have this server executable. Let's go ahead and start that up, and let's see what happens. Okay, so we did the get address info, we did the socket, bind, listen. Oh, and we had a client connect. Who is this guy? Well, I can sort of recognize the IPv6 address shown here. This is the health probe I was talking about just a moment ago. Just ignore that guy. That's a robot checking our server. Okay, so this is great. The server is running. It's waiting for another connection. By the way, that template that you clicked that button for deploy to Azure, there we go. Okay, this guy, this button here, when you click that, the default is for the health probe to hit your server every 30 seconds. So let's jump over to Azure and let's take a look at it. So if you have to go into load balancer, And then under health probes, click on this guy, and you can change the interval to whatever you want it to be. So that's the number of time between, the amount of time between probe attempts. If I go to insights, we can, let me close metrics. It says our server is unhealthy right now, but I think the more the probe hits it and see that it's getting data, yeah, so now the average health probe status, it went up, but it's still in the unhealthy state. I think it has to get to 50 for it to be partial yellow, and then basically like 90 or 100 green, which means it's healthy again. So basically it's going to keep hitting our server, and then after it hit it enough times, it's going to start believing, okay, this server can actually handle some traffic. So it just went up again. Let's see. So if I go on the health probe, just to speed things up, let me put this down at 5. And let's go watch our server. Oh, it's not auto-scrolling. Okay, so it just hit, but couldn't really tell that, okay, everything's kind of flickering. It's because the health probe is hitting a lot more now. And let's see what our health status is. What's the metric? Okay, so now we're yellow, partial, we're at 50. So this is a lot better. So it hit us a few more times and it sees that, okay, the server seems to be working. So that means hopefully the load balancer will let us through. So if you head over to your IPv6 public IP address on Azure, I'm going to copy this guy. I'm going to go to a web browser and open a new tab. And in order to, let me just put it on here so you can see it better. In order to use IPv6 addresses in a web browser, you have to put the IP address inside square brackets, and then you can still specify the port as usual. So this is what I'm going to paste into the address bar of my browser here. Paste, hit enter, and let me zoom in on that. And we have been given the IPv6 server time is, and then the time. And if I hit F5 and refresh, we should be, yeah, so the seconds is changing right there. Very cool. And then, oh, and sometimes that happens if we get interrupted by the health probe. Let me give you a nice side by side. So we're sitting here waiting. If I refresh, we can see there was a connection. For some reason, okay, there the browser loaded it. And look at this IP address. So let's copy this IP address, refresh again. Yeah, this IP address right here, let's look that guy up. Who's public IP? We'll use this who is lookup. Enter the IP address here, look up. That is Cox Communications, which is my internet service provider here in Las Vegas, Nevada. So that pretty much summarizes this video. In this video, we saw what is IPv4, what is IPv6, what is the point, why should we care, since this does not affect our user-facing interface. What's the story there? We learned about that. We learned it's more cost-effective because IPv6 addresses are far more plentiful. We learned how to write shorthand for IPv6. We did not talk about how to deploy an IPv6 server on Azure, but I gave you that one-click button to do it so that we can do the demo code in this series, or in this video, I should say. And we also saw in this video how easy it is to change the server code to start accepting connections for IPv6. Thanks so much for watching, and I'll see you in the next one. Take care. Bye-bye.